if you have z1 which is equal to a plus bi, and z2 which is equal to x plus yi. So how do we multiply this one and how do we divide? For multiplication, if we have z1 times z2, it means it is a times a plus bi, then times x plus yi. You remember that for the addition, normally we add like terms. We add real part with real part and add imaginary part with the imaginary part. But here, we take this a, which is the real part, to the whole set z2. So we take a times x plus y, then we add bi times x plus yi. So it means we get ax plus ay, this times this, then plus xbi, then plus byi squared. So this one is a real number, and this one will become a real number because I squared is equal to negative 1. So it means we get a plus ax plus by, because they are all real, then we add ay plus bx, then I. That is how we multiply complex numbers. For example, we can take like z1 which is equal to 3 negative I, and z2 which is equal to 2 plus 3i. So for their multiplication, z1, z2, it will be equal to this number times this, which is 6, 3 times 2, this one times this, then this one times this, plus 9i, then this number times this one, it will be negative 2i, then again this number times this one, so we will get negative 3i, negative 3i squared. This is equal to 6, this I squared is negative 1. So negative 1 times this is positive 3, then this I with this one, we get plus 7i. So this is equal to 9 plus 7i. This is how we multiply the set of complex numbers. What about addition? What about division? What about the addition? For division, we will need to take z1 over z2 or z2 over z1, which is equal to a plus bi over x plus yi. So after writing like this, normally we need to put this in standard form. So when we need to put this in standard form, we need to multiply the conjugate of the denominator. Hope that you have seen how to find the conjugate in the previous videos. You will check. There is no problem. So we multiply the conjugate of this denominator, which is x negative yi over x negative yi. This is the conjugate, and this is normally called like rationalization. Now, if we multiply like this, we will get automatically this times this ax, this times this negative a yi, this times this plus bxi, this times this negative byi square, dividing with this times this, which is x squared, then this times this negative yi squared. This is equal to what? When you check this one very well, you see that this will become a real number, because this I squared is negative 1 and it will become positive. So it is ax plus by. Then this and this, we add bx negative ay. We divide with, this will be I squared, as you see, x squared, then plus y squared. This is squared. Now, this is how we find this division, and when you look at this, you see that the denominator now has become a real number, not a complex with real and the imaginary. It is only a real number. Even if it is an imaginary part, you need to conjugate. You need to conjugate and you rationalize with the conjugate. Now, an example here, we can take like z1, which is equal to 3, negative I, and z2, which is equal to 2 plus 3I, as we used for the multiplication. Now, z1 over z2, it will be 3 negative I over 2 plus 3I. So it will be, we multiply with the conjugate, as we have said, 3 negative I over 2, sorry, it is 2 positive 2 negative 3I over 2 negative 3I. We rationalize the denominator. Now, when we are going to multiply, we get this term with this, we get that this is equal to 6. This term with this is equal to negative 9I. This term with this, negative 2I. This term with this, positive 3I squared. We divide with this term with this, 4, and this term with this, negative 9I squared. This is equal to what? This, normally this one become negative 3, because I squared is negative 1 times this, we get negative 3. So it is z1 over z2, it is equal to 6 negative 3, then negative 9 negative 2, which is equal to negative 11I, dividing with 4 positive 9. Why positive? Because I squared is negative 1, and then negative 1 times this, it is positive 9. So this one is equal to 3, 6 negative 3 is 3, negative 11I over 13. This is how we find the division of complex numbers. Thank you very much. Don't forget to subscribe, don't forget to like, and don't forget to add a comment if you have a question or if you have a suggestion. See you next time.